Hi everyone, myself Navyatha Ravi, working as Assistant Professor in MLR Institute of Technology in CS and Data Science Department. Today we are going to discuss about additional features of ER model. So these concepts includes key constraints for ternary relationships, participation constraints, weak entities, class hierarchies and aggregation. So before going to deal with this topic, in our previous lecture, we have already discussed what is ER model. What is ER model? So ER model stands for entity relationship model. So what is entity? It is nothing but a real world object which can be a living or non-living thing. So it can be a student or college and which is represented by a rectangle symbol, right? So what is a relationship? To relate these two entities, we use a relationship which is nothing but represented by a diamond symbol. So student studies in college. Student studies in college. That is what relationship. And along with these two, we have already discussed about what are the different types of attributes. So what is an attribute? It is nothing but the property of an each and every entity is called as an attribute. So what is meant by attribute? So for example, each and every student have roll numbers, right? So roll number, name, mobile number. So these are nothing but attributes which defines the properties of a particular entity, and these attributes are represented with the oval symbol, right? So here this is the description which was dealt in the last video, and now we are going to discuss the additional features of ER model. So which includes the first one, key constraints. Key constraints. So what is meant by constraint? In the context of DBMS, so constraint is nothing but a set of rules. Why? Because we are dealing with the database, so we must follow some rules and regulations to maintain the database in a consistent manner. So that is the reason we have to follow some rules and regulations, and in DBMS context, those rules can be considered as constraints. So here coming to the key constraints, these are nothing but the rules that are to be followed while entering data into columns of the database table. Here I used to deal with the entering of the data, the entry of the data in the form of tables. That means I am going to enter the data in rows and columns. So for example, here student ID, this is student name and this is mobile number, right? So here I used to enter the data in a database by using tables, that means rows and columns. For example, let us consider some ID, name and mobile number 1, 2, 3, 4, 5, 6 like that, right? So if at all I used to deal with the data entry in the form of tables, then that is called as relational data. That we will discuss in the later slides. So here constraints are nothing but the rules that are to be followed while entering the data into columns of the database table. Constraints ensure that data entered by the user into columns must be within the criteria specified by the condition. So this means, for example, if at all I want to enter the data whose age is greater than 18. I want to enter the data whose age is greater than 18. Whose age must be greater than 18. Then first I should specify that age column in my database. For example, student ID, name and age. And if I want to enter the data, for example 20, if I want to enter the data 20, then what the database will restrict? Why? Because here I should represent my age must be greater than 18. I am very sorry. The age must be less than. Age must be less than 18, and here I am going to enter 20. So here the constraint is violating. That is the reason. So DBMS came into existence in irrespective of file systems. In file systems we can't correct, right? So in DBMS, even without the entering the data itself, it will restrict. Why? Because here you have given the constraint, here you have given the rule that you must enter the age less than 18. But here you are going to enter the age greater than 18, then it will be restricted. That is the beauty of DBMS, right? So, for example, if you want to maintain only unique IDs in the employee table, or if you want to enter only age under 18 in the student table, just now I said. So, next we have 6 types of key constraints here. So, what are those types? Not null, unique, default, check, primary key and foreign key. So, here these are as we have already discussed about the primary key in the previous slides. What is the primary key? Which is used to represent the unique data. That is nothing but if at all my data is in the table format, SID and SName, here the roll numbers are unique. Roll numbers can't be repeated. Your roll numbers must be unique. So, here SID stands for student ID and that must be unique. So, these are nothing but the primary key here. The column SID can be considered as an primary key. Why? Because it will accept only unique values and that column must be considered as a primary key. That we have already discussed in the previous sessions. Now, let us discuss all these one by one in detail. What is not null? Which ensures that specified column does not contain null values. That means we have to enter any of the values, either duplicate values or else some other values, right? So, but the data must be we must ensure that the data must be present. For example, name will be XYZ and SID 20. Here I didn't mention any name. If at all, I used to represent this column as unique, this column as not null. I used to represent this column as not null. That means this column will not accept null values. But here I doesn't give any value. That is the reason it will restrict. That means what the DBMS will tell us? You are violating the constraint. You are violating the rule. That is nothing but this column has been declared as not null, but here you are not giving any value. That is the pop-up message you will get. So, ensures that not null ensures that the specified column does not contain null value. The next one is unique. Provides unique or distinct values to specified columns. That is nothing but, let us consider this table, the same table, SID and name with 2 columns. First, suppose here I used to give the same ID and I have declared this column as unique. I have declared this column as unique and this name as not null. How we have to declare also I will tell you in the later on slides, how we have to declare, how we want to represent these type of queries in SQL, right. So, if at all I used to declare SID as unique, then here I want to give the same ID, then it will again restrict. Why? Because here already 2 has been given, already the ID has been existed, right. So, it will not accept again the same value. If at all we used to declare it as an unique. So, unique constraint provides a unique distinct values to specified columns. Next, default provides a default value to a column if none is specified. For example, let us represent address which is of type, for example, character type which contains 20 characters. So, whatever the variable that we used to declare, then it must be declared with a data type and with the size of that data type. So, address character of some 20. Next, here in quotations, let us represent Hyderabad. So, in between, if at all we used to represent default key, then automatically that column, the column will be printed as Hyderabad. For example, SID and address. This is the column, right. So 1, 2, 3. So what is the address here, which is of character type, and I used to print default Hyderabad. So for each and every row, Hyderabad will be printed, irrespective of entering each and every row, each and every time, and for each and every tuple, irrespective of entering Hyderabad every time. By single line, we can able to represent Hyderabad here. Default, it will take, the column will be taken Hyderabad, right? So what is next one? The check constraint. Check constraint checks for the predefined conditions before inserting the data inside the table. That means, let us take one example. For example, I am creating a table, create table. Table name is nothing but student, which consists of attributes SID, comma, SName, comma, SAge, student ID, student name and student age. So how I used to represent here? For example, I am taking the age constraint must be less than 18. So here I used to represent SH, which is of integer data type, and here I used to check what age must be less than 18. So in this manner I used to represent. So what it will check whether I am going to insert the age less than 18 or not. If at all I am not going to follow this constraint, then it will restrict to enter the data into the database. That is the main purpose of check constraint. Next, primary key. It uniquely identifies a row in a table. As I said before, what is foreign key? So, which ensures referential integrity of the relationship. For example, let us deal this one with a basic example. Let us consider two tables. The first one is student table, the second one is marks table. This is student table and this is marks table. So, here let us consider SID as primary key and here name. Here also let us consider SID and here marks. For example, first row may contain the data and second row may contain the data. And for the first roll number 1 marks, he got the marks 100. For roll number 2, he got the marks 200. So, how we want to relate these two? So, to relate two different tables, here comes the concept of foreign key. So, in foreign key, one key acts as a foreign key in a table, which acts as a primary key in another table. So, I am repeating it again. A foreign key is a key which acts as a primary key in another table. That means, let us consider this marks table. So, here consider SID as foreign key. Consider SID as foreign key. So, this SID will act as a primary key in another table. That is what the relation. To relate two different tables, so we use foreign key concept, and the foreign key is a key which acts as primary key in another table. So, these are the basic in key constraints that we used to learn. And here we are dealing with ER model. Here we are dealing with ER model. So, obviously, we need to represent it in a diagrammatic format, right? Here we all know that entities are represented with rectangles, attributes are represented with ovals, and the relationships are represented with rhombus or diamond symbol. So, the relationship here, employees manages department. This is one entity, this is another entity, and this is what we call as relationship. So, employees manages department. So, here we used to learn two more things, that is nothing but partial participation and total participation. Let us discuss this one. Employee has how many attributes? Two attributes, name and number. Employee number might be a primary key here. Why? Because here number represents employee ID and all the employee IDs must be unique only, right? And department name and department budget. So, here the relationship between employee and department here is each and every department will be managed by at most one employee. Each and every department will be managed by at most one employee. Let us take one example. That means in a college, we have number of departments. We have number of courses like CSC, IT, EC, EEE. And each and every department will be managed by head of the departments, and he or she must be only one, at most one. Only one person will manage the whole department. That is the basic example for this one. Each and every department must be managed by a single employee. So here this represents, this arrow mark represents, that is the thing. What is the thing? Each and every employee, right, must be, or each and every department must be managed by one employee only. And here, but all the employees will not manage the department, right? Any one of the employees only will manage the department. So, the relationship for the second one, let us represent this one. Employee works in department. All the employees works in departments, right? So, here the arrow mark represents only the single person. That means each department will be managed by only one employee. And here all the employees works in departments. So, here the double line represents, the thick line represents total participation, and single line represents partial participation. So, this will be dealt clearly in participation constraints. The next one is key constraints for ternary relationships. As we already discussed earlier, what is ternary relationship? If at all a relationship contains exactly three entities. If at all a relationship, this is the relationship contains exactly three entities, then it is called as ternary relationship. So, we have three types of relationship: unary relationship, binary relationship, and ternary relationship. Unary relationship means a relationship contains only one entity. So, for that we have already discussed an example. What is that example? A person married to a person itself. A person married to a person. So, here we have only single entity which is connected to a particular relationship. That is what we called as unary relationship. So, what is binary relationship here? Binary relationship. If at all a relationship is in between two entities. For example, student studies in college. Student studies in college. Here we have two entities. So, study in, this is what we called as relationship. We have two entities related to a particular relationship, then it is called as binary relationship. Next, what is ternary relationship? If at all a relationship contains three entities, then it is called as ternary relationship. So, here employee works in departments in some particular locations. So, here we have another attribute, that is what we call as since. So, this attribute is called as what? Descriptive attribute. Descriptive attribute. So, if at all the attributes are connected with the relationship, then those attributes are called as descriptive attributes. So, here each employee works in at most one department and at a single location. So, here the arrow mark is where each employee, each and every employee works in at most one department and at a single location. So, here SSN can be considered as primary key, and department ID can be considered as primary key, and address can be considered as primary key. So, how can I able to identify those things? Why? Because they are underlined. So, in ER diagram, within the attributes, those attributes are underlined, then those attributes are nothing but considered as primary attributes, primary key attributes. So, this is what key constraints for ternary relationship. Next, participation constraints. So, here what are the participation constraints? We have two types of participation constraints. What are they? Total participation and partial participation. So, if in an entity set, if each and every entity is participating, in a relationship, then that participation is called as total participation, else partial participation. So here, let us consider the same example which I have dealt before. Employee manages departments. See here, each and every department will be managed by at most one employee. So in this, each and every department, that means in departments entity set, each and every department has been related to this relation. Each and every department must be managed by an employee. So this is nothing but comes under total participation. But every employee must not be a HOD, right? That is the thing. That's why it is partial participation. Especially this relation is nothing but partial. This is total. Now let us consider this relationship excluding managers. Let us consider this relationship. Employee works in departments. Employee works in departments. So here we can consider as employee, double line. Each and every employee works in departments, right? So this can be considered as also total participation. Why? Because each and every employee works in department, right? So that can be also considered as total participation. So that is the basic difference between total and partial participation. So if every department must have a manager, then there is a participation constraint. What is that participation is called as total participation. The participation of departments in managers is total. Here he used to deal with this particular example. That is what about participation constraints. Now let us deal with weak entities. So here we already know that what is an entity? It is nothing but a real world object that can be a living thing or non-living thing. So how many types of entities are there? We have two types. What are they? Strong entity, weak entity. Strong entity, weak entity. The entity set that contains primary key, that is called as strong entity. The entity set that doesn't contain any primary key and it depends upon some other entity to define uniquely, then it is called as weak entity. The strong entity is represented by only single rectangle and the weak entity is represented by the double rectangle. And the relationship between strong entity and weak entity is called as identifying relationship. So let us deal with an example. So an entity that cannot be uniquely identified by its own attributes and relies on relationship with other entity is called as weak entity. So here let us take two entities. Customer is an entity, loan is another entity. So customer can be uniquely defined. Why? Because here customer ID, this can be considered as a primary key, which has a primary key, and customer name. That's why it is called as strong entity. Let us consider loan. Loan name, loan date. So here loan name can be duplicate. Loan name, the same loan can be taken by many number of persons on the same date, right? So that's why we can't uniquely identify this entity particularly. That is the reason this entity is called as weak entity. Why? Because it doesn't have any primary key to uniquely identify that particular entity. So this depends upon the strong entity, and the relationship between these two is called as what we called as identifying relationship. Identifying relationship. So customer borrows loan, and this identifying relationship will be represented by a double rhombus or double diamond. So the weak entity is represented by double rectangle and the identifying relationship are represented with double diamond. So that's what about weak entities. The next one is class hierarchies. So what is meant by hierarchy? Hierarchy is nothing but a protocol from top down to or bottom up approach we used to deal with. For example, in college management side, if at all I used to complain about a lecturer, if at all I am a student and I can't able to understand the lectures delivering by our lecturers, then whom I should first represent? Directly I can't go to the principal, right? We should follow some protocols. First of all, I should intimate to a class teacher. Then I should intimate to a HOD sir. Then I should intimate to a principal sir. So this is a hierarchy that I used to follow, right? So in the same manner, we used to, if at all we used to design a database, we used to follow some hierarchy. We have two types. So, class hierarchy can be viewed in one of two ways. So, what are those two ways? Specialization and generalization. So, here specialization is nothing but a top-down approach, and generalization can be represented as a bottom-up approach. So, top-down approach. Let us discuss with this an example. Let us consider a vehicle. A vehicle can be a car, a bus, or a cycle. Car, bus, or a cycle. Vehicle can be car, bus, or a cycle. So, let us consider this one with a top-down output. Let us consider one entity, the main entity, vehicle. It can be subdivided into 3 or more classes. These are called as what? Subclasses. This is the main class and these are called subclasses. So, this is what we call as top-down approach. From the top entity, we used to subdivide the bottom entities. A vehicle can be a car, a vehicle can be a bus, and a vehicle can be a cycle. Right? What is bottom-up approach? First of all, we used to consider all the entities individually. Let us consider car, let us consider bus, let us consider cycle. We used to generalize the properties of these three things, and we used to unite the properties, and we used to make them under one entity, that is called as the main entity, vehicle. Top-down approach is nothing but we used to subdivide the subclasses from the parent class. What is bottom-up approach? Bottom-up approach means here we are dealing with the subclasses and we used to unite these subclasses based upon some basic properties into a superclass, right? That is the thing. So, what is specialization here? It is a process of identifying subsets of an entity that shares different characteristics. It breaks an entity into multiple entities from higher level, superclass, to lower level. So, one main entity will be considered, that main entity will be divided into sub-entities and superclass will be divided into subclasses. What is generalization? It is a process of generalizing an entity which contains generalized attributes or properties of generalized entities. The entity that is created will contain the common features. So, what are those? Generalization is nothing but a bottom-up process. So, let us deal with these two with an example. As I said, vehicle is a car, truck or motorcycle. So, top-down approach, in top-down approach, first of all, we used to consider the main entity and that will be divided into sub-entities. In bottom-up approach, first we used to consider three individual entities, we used to generalize them, unite them by considering the similar properties of these three, and we used to generalize it as a superclass. So, it is nothing but bottom-up approach. This is what we call as top-down approach. So, top-down approach is called as specialization, bottom-up approach is called as generalization. So, till now we have discussed about the key constraints with the ternary relationships, participation constraints, so these are some of the additional features of ER model. Till now we have discussed, and in later on session we used to discuss about the relational model and conceptual model of database design. And the last one is aggregation. So, what is aggregation? Aggregation is a process of combining two or more entities to form a more meaningful new entity. So, we already discussed about entities. To relate two or more entities, we use aggregation here. So, this is one entity, visitor, a single entity, and this is one more entity. The whole thing is nothing but another entity. This is another entity. We used to relate these two entities. Why? Because to get our design in a more meaningful manner. So, aggregation is a process of combining two or more entities to form more meaningful new entity. So, here a visitor inquires about the center who offers course, or else here let us deal with another example. Student enquires the centers. Student enquires the center which offers course, right. So, here this entity, this gives what more meaningful representation than we can represent this one by using ternary relationship also. We can represent the same diagram by using ternary relationship. That means, for example, let us consider one relationship which contains 3. This is one entity, this is another entity, this is another entity, and this is one relationship. We have 3 entities. Here, for example, visitor, here center, here course. So, visitor enquires about the center and about the course. The same diagram can be represented in this manner also. But you can easily identify that this is more meaningful than considering the ternary relationship, right? Why? Because here 2 relationships we can able to connect the 2 relationships. Visitor enquires about the center who offers the course. So, aggregation is the process of combining 2 or more entities to form a more meaningful new entity. As I said, visitor enquires about the center which offers course. Here we can consider this one is one entity and this is another entity. And one more thing, if at all we used to combine 2 relationships, we used to relate 2 relationships, then that is only possible through aggregation. See here, in each and every diagram, we used to relate entities with a relationship, right? These are the entities and these entities connected to a relationship. But here in aggregation, we can relate 2 different entities. That is only possible through aggregation. So, in this, the summary of this session is nothing but we have discussed about additional features of ER model, which includes key constraints, participation constraints, aggregation, and next specialization, generalization. So, these are the things which we have concluded, right? Thank you.